the real world, nobody multiplies matrices by hand. Why? Because it's a total pain. They use computers. But it's good to know how it works. One, because probably in class you're going to have to do it by hand just because. And two, once you get to the stage where, if you go on with math and you actually deal with matrices to solve real world problems, you'll use computers to multiply them, but it's good to know how it's actually working in the background. So a lot of people get intimidated by multiplying matrices. It's not that confusing. It's more that it just involves a lot of work, as in like it takes up a whole sheet of paper to do a multiplication. So it's kind of more just a pain rather than it being overwhelming or confusing as a concept. So I'll try to explain this clearly, and I've kind of have this model set up, which I think will allow you to multiply matrices without panicking. To me, this makes it clear. You'll see in your textbooks complicated formulas for multiplying matrices. I don't know. Ignore those. It's really a lot simpler than they're trying to make it. Okay, so just a point of clarification. This is not multiplying a matrix by a scalar. Taking a matrix and multiplying it by the number 3. That's very easy. You just multiply each element by the number 3. This is multiplying two matrices together. Okay, there's one condition that has to be true before you can actually multiply matrices. Um, if you're multiplying two matrices, matrix A and matrix B, let's call them, the number of columns in A must match the number of rows in B. Otherwise, you can't do the multiplication. It would be undefined. So these are rows. Row, row, column, column, column. So this matrix has 2 rows and 3 columns, so it's a 2 by 3 matrix. Okay, but I'm going to erase all that. So if A is a 2 by 3 matrix and B is a 3 by 7 matrix, um, then then the number of columns of the first matches the number of rows in the second, so that's good. You can do that. Okay, furthermore, the dimensions of the new matrix, the matrix that is the product of these two, will then have the dimensions 2 by 7. So if you put their dimensions together, um, then these two kind of inner numbers need a match. I should make that yellow. These two inside numbers should match, and then the outside numbers are kind of what forms the new dimension. So if you have a matrix that's m by n, multiplying a matrix that's n by p, okay, the columns matches of the first matches the rows of the second, okay, and then your new dimensions will be m by p. Okay, so here's my little model. So this matrix is a 2 by 3 matrix. It's got 2 rows and 3 columns. This matrix is a 3 by 2 matrix. It's got 3 rows and 2 columns. So the number of columns of the first matches the number of rows of the second. The dimensions of the new matrix will be 2 by 2. So 2 rows by 2 columns. Okay, here's where it gets slightly complicated, but not too bad. To get to the new values of the new matrix, you're multiplying the rows of the first column of the first matrix by the columns of the second matrix. And here's how it works. Here's how I remember. Okay, here's the process is I would actually draw the new matrix empty. You don't know what the numbers are yet, and then just go element by element and say to yourself, what element is this? So the coordinates of each element is what row it's in by what column it's in. So for example, this element here is in the second row. So there's 1, 2 rows. It's in the second row, and the first column. There's 1, 2 columns, and it's the first column. So the location of this element is row 2, column 1. Well, to get this value, I therefore multiply the second row of the matrix, the first matrix, uh, by the first column of the second matrix. Okay. So multiplying matrices goes in one direction. It's not multiplying A by B is not the same as multiplying B by A. Okay. So we're multiplying the rows of the first column. Sorry, I keep saying that. Multiply the rows of the first matrix by the columns of the second matrix to get your product. Okay. So this is element 2, 1, meaning it's in the second row, first column. That means I multiply the second row of the first matrix by the first column of the second matrix to get the value of this element. Now, what does it mean to multiply a row by a column? That means I multiply each corresponding element and I add them together. So, so to multiply this second row by this first column, I multiply the first element in the row by the first element in the column. I multiply the second element of the row by the second element in the column, and I multiply the third element in the row by the third element in the column. That's why the number of columns of the first matrix has to match the number, or has to match the number of rows in the second matrix so that these things match up. 8, 2, 9, 3, 10, 4. If there was like a 5 down here, then, what would I multiply with that 5? Okay, so I do those multiplications, and then I sum those together. So 8 times 2 is 16, 9 times 3 is 27, 10 times 4 is 40, then add up 16 plus 27 plus 40 equals 83. So this element is 83. This is why multiplying matrices is a pain, right? That's a lot of work just to calculate the value of one element. But so be it. That's what you do. That's why we use computers to do it now. Because when you're multiplying matrices in the real world, they're not going to be this simple, and it's just you don't want to fill up 3 pieces of paper just to calculate it, especially when you're probably going to make some arithmetic errors, as I might make when I'm doing this. I'll try to be careful, but it's possible. But the process is what we're focusing on. Okay. All right. So let's try it on a real example here. I've got matrix A, matrix B. So let's see what their dimensions are. So I've got 2 rows. By 1, 2, 3 columns, and then I've got 3 rows. 1, 2, 3 by 1 column. Okay. So let's put these dimensions together. Okay, these numbers match, so we can multiply them, and then these become our new dimensions. So our new product is going to be a 2 by 1 matrix. So we're going to multiply A times B. So A times B will equal a 2 by 1 matrix. So it's 2 rows and 1 column. I did that on purpose, so it's the simplest, a very simple matrix, right? 2 rows and 1 column. So there's just going to be 2 numbers in here. Okay, so there's going to be this number and this number. So let's find the value of each one. Okay, so what is the location of this element? Well, it's in the first row and the first column. Row 1, column 1. That means I multiply the first row of matrix A by the first column of matrix B. Okay, so I multiply the corresponding elements. So the first element in the first row by the first element in the first column. Second element in the second row, or first row, second element in the column, first column. Okay, so let's do that. So 1 times 7. 1 times 7 plus 8 times 5 plus 5 times 3 So 1 times 7 is 7, 8 times 5 is 40, 5 times 3 is 15. Let's add them all up. 7 plus 40 is 47, plus 15 is 62. So that first element, 62. I'm going to switch colors. I kind of don't like this yellow for some reason right now. 62. Alright, so we're good on that calculation. Now, what is the value of this element? Okay, its location is, it's in the second row, row 1, row 2, first column. Second row, first column. So that means I'm going to multiply the second row of A by the first column of B to get the, and then add them together to get this value. So now we're dealing with this row, row 2, and again column 1. So 2 times 7 plus 3 times 5, 3 times 5, plus negative 2 times 3. Negative 2 times 3. So 2 times 7 is 14, 3 times 5 is 15, negative 2 times 3 is negative 6. So 14 plus 15 is 29, minus 6 is 23. So the value of that element is 23. And then we're done for that. So I picked a very, very simple one so I could fit the work. But you can see already just 2 elements, that's a lot of work, okay? So multiplying matrices does not get any more complex than that. It'll just take longer than that, okay? So, just to summarize, to multiply 2 matrices, the number of columns of the first one must match the number of rows of the second, and then the dimensions of your new matrix will be the number of rows of the first by the number of columns of the second. Okay, draw your new matrix with its dimensions, and maybe like put little spots for the elements, and then go step by step asking yourself, okay, what is the location of this element? Well, if it's in the first row in the first column, that means I multiply the first row of matrix A by the first column of matrix B. If it's in the first row, second column, that means I multiply the first row of matrix A by the second column of matrix B. And what does it mean to multiply a row by a column? It means to multiply each corresponding element. So 8 times 2, 9 times 3, 10 times 4. You know, first, second, third, first, second, third. And then I sum those products all together. And that's the value of my new element. Alright, I wish you all the best. Good for you for tackling matrices. I challenge you not to be intimidated by them and to just embrace them and enjoy doing multiplications. And hopefully with this model in mind and this process, it should be a breeze for you, and it should be fun. Alright, good luck. See you later.